Here's a handy socket nut driver for securing and unfastening bolts. Granted, you aren't going to be able to use this for torquing down cylinder heads or removing rusted bicycle bolts, but even printed in PLA on an FDM machine, you'll find it's a handy 3D printed tool. So stick around. There's a couple of assembly options that we cover that you should know about if you want to print one of these for yourself. Printable Science presents a 3D printed socket nut driver. Your basic socket is just a cylinder that has a knockout on one end for fitting over the bolt or nut that you're fastening, and a square hole on the other end for fastening to a ratchet handle or driver. There's 3 standard sizes for that square drive hole: 1/4 inch, 3/8 inch, and 1/2 inch. And to make things easier, we provided drivers for all 3 sizes. Now, while socket ratchets are cool, and we will be making one in an upcoming project, a ratcheting driver for our needs is not only overkill, it actually makes the task more difficult than it needs to be. Now, the shaft can be pretty simple, just a square block on the end of the handle that fits into the drive end of your socket. But you'll be relying on a friction fit in order for the socket to remain on the shaft. If you look at commercially available ratchet handles, you'll see they address this problem with a small spring-loaded ball bearing in the side of the block. If you look at a corresponding socket, you'll see there's an indent on each side to receive the protruding edge of that ball bearing. When you slip a socket onto a handle, the spring-loaded ball is easily pushed into the drive cube, and when the socket is seated, the ball is pushed out by the internal spring, and that serves to hold the socket in place without it falling off. Tiny ball bearings and even smaller springs are a bit out of our league. We try to make our projects rely as much as possible on projects that use 3D printed parts, and where that's not possible, to use commonly available inexpensive parts. Our solution to this problem in this situation is to use a BB for the small ball bearing. You can pick up a small bottle of them for a few dollars, and don't despair, there are other projects that you'll be able to use your BB collection for. As for the spring, we're going to use a tiny piece of flexible filament. And while it certainly won't be worth your while to go out and purchase a whole roll of flexible filament just for this project, I'm pretty sure that everyone has a roll of this stuff because you all thought, oh, flexible filament, that's so cool. I'm going to print up some rubber gloves, only to find that printing with flexible filament is not the easiest thing to do. I'm fairly confident almost everyone has a roll of the stuff tucked away somewhere, and if you really can't find any, let me know in the comments. Should be easy enough to get you a few inches of the stuff that would be good enough for making 100 or more of these drivers. If you print off a shaft with a hole in the driver end, this is all you have to do to get it ready. There's a small hole in the top end of the shaft, and you can slide in a piece of 1.75 millimeter flexible filament. Once you've done that, back off just a tiny bit and cut the filament, and then, using some non-flexible filament, push that small piece of flexible filament back into the hole until it seats properly. Now, you just need to put a small bit of glue to secure the filament in place, as repeated use will find that the small piece works its way loose. We use some epoxy for this task, and of course we highly recommend the use of our epoxy workstation for this and all your gluing needs. You'll find a link to the video up here. Now, all we need to do is insert the BB ball bearing. The hole on the side of the shaft is undersized, and so we have to do what's called a press fit in order to get it in place. We've crafted the hole so it's just large enough that you can press the ball bearing into it without cracking the shaft. Once the ball has been pushed into the hole, the perimeter that was deformed in order to allow it to pass resumes its shape, locking the ball in place. And because in this application there's no appreciable force pushing the ball out of the socket, we can be fairly confident it's going to remain. We've even included a press so you can perform this press fit with ease. At least I thought we provided one. Here we are, right here. If you're having trouble getting the BB installed, try warming up the shaft a bit to make the plastic more pliable. All you need to do is put the shaft in the press, put the BB on top, and then screw down the bolt until it pops into place. So there we have it, a socket driver that can be slipped into a socket and hold it in place just like the big boys. We have included shafts without bearing holes just in case you want to create a custom driver for a popular socket size. In that case, you would glue a socket directly onto the shaft, but we don't expect you to sacrifice a fancy metal one for that purpose. Our next video will provide you with some STL files for printing off a whole bunch of different sockets. If that video is ready, you can follow this link up here, and if that didn't show up, that just means the video isn't ready yet. To finish assembly of our driver, you just have to glue the shaft into the handle of your choice. We've provided both a T-bar and screwdriver-like handle that you can use as per your preferences. We printed the shafts and handles in PLA with a 0.2 millimeter layer height, 2 bottom and 3 top layers, and 2 perimeter layers. You can print your handles with a 15% infill, but for strength, print your shafts with at least a 75% infill. If you're a Patreon supporter, be sure to check our Patreon page to find out how you can get customized files for your drivers, change the shaft length, diameter, and handle, whatever you want. As we mentioned earlier, you're not going to get away with using these drivers for heavy-duty industrial work. But for most home use, and particularly for fastening 3D printed parts together, you'll find they're more than adequate. And anyway, perhaps the day of the consumer-level metal 3D printer is not all that far away. And when that day comes, you'll be able to use these files to print off something that's just as strong and durable as a Snap-on or Craftsman product. Thanks for watching. And won't you help by becoming an important part of the Printable Science family and making this channel more valuable and successful? You can help us out by taking the time to watch this video in its entirety, and the other Printable Science videos as well, perhaps while your 3D printer is printing off this project. You can leave comments and questions below. That will help us to continue to create useful videos and 3D STL files that are pretty ready and help you to maximize the power and utility of your 3D printer. Your feedback is very important. If you've enjoyed this video, please click the thumbs up button, and if you have just a moment, won't you show your support by clicking the subscribe button below. If you want to make sure you don't miss our upcoming videos on 3D printing, you'll want to click on the notify bell as well. And please, consider supporting Printable Science on Patreon using the link supplied below. You can become one of our Patreon supporters for as little as $1 a month, and it will provide you with lots of extras and additional information, as well as going a long way to help defray the cost of making these files and videos. Down below, you'll also find a link where you can download a copy of the STL files from Thingiverse so that you can create your own socket nut drivers and handles. As always, you can download a copy of the STL files for this and other projects directly from our website. The latest files and a discussion board on the 3D printed socket ratchet or socket handle are available at the printablescience.com website, where all the science that fits, we print.